So at the end of class on Friday, when I was recording our class, I pushed the power button instead of the stop button, and nothing that I recorded saved. So I'm going to quickly go through these notes, and hopefully this will take care of things. So today we looked at two specific types of sequences, arithmetic sequences and geometric sequences. An arithmetic sequence is a sequence where the differences between consecutive terms is constant. An arithmetic sequence is a sequence where the differences between consecutive terms are constant. Arithmetic series, a sequence where the differences between consecutive terms are constant. For example, in 4, 7, 10, 13, 16, if I find the differences between consecutive terms, 7 minus 4 gives me 3. 10 minus 7 gives me 3. 13 minus 10 gives me 3. 16 minus 13 gives me 3. This is an arithmetic sequence, and we're going to say that our common difference is D equals 3. D is our symbol for the common difference. D equals 3. There might be an easier way to think about this pattern rather than the differences being constant. We can also say this looks like an addition pattern. 4 plus 3 gives us 7. 7 plus 3 gives us 10, and so on. In the next example, well, to go from negative 14 to negative 20, we're going to add negative 6. To go from negative 20 to negative 26, again, we're going to add negative 6, add another negative 6 there. You could also check the differences. You could do negative 20 minus negative 14. That's negative 20 plus 14. That's negative 6, and so on with the others. This is an arithmetic sequence, and our common difference is negative 6. When we have an addition pattern, we call it arithmetic. The other type of sequence is a geometric sequence. In a geometric sequence, well, we have a sequence where the ratios between consecutive terms are constant. It's a sequence where the ratios between consecutive terms are constant. For example, 5, 15, 45, 135, if you find the differences between the terms, 15 minus 5 is 10, 45 minus 15 is 30, there isn't a common difference there. However, if instead of looking at differences, we look at ratios, well, 15 divided by 5 gives you 3, and 45 divided by 15 gives you 3, and 135 divided by 45, use a calculator if you need to, will give you 3. 5 times 3 gives us 15. 15 times 3 gives us 45. 45 times 3 gives us 135. It's geometric, and our common ratio, the thing we're multiplying by every time, is 3. Whereas an arithmetic sequence was an addition pattern, a geometric sequence is a multiplication pattern. In the next example, well, we could start doing some division, and you can do this on the calculator as long as you're careful with your parentheses. Negative 3 halves in parentheses divided by 3. 3 fourths in parentheses divided by negative 3 halves in parentheses, and so on. Or you can look to see what we're multiplying by. 3 times what gives you negative 3 halves? Well, negative 1 half. Negative 3 halves times another negative 1 half will give you positive 3 fourths, and so on. This is a geometric sequence, and our common ratio is negative 1 half. Take a look at the 3 problems on the bottom of the page. Figure out if they're arithmetic, geometric, or they don't have to be either of them. If there is no common difference and there is no common ratio, then we're just going to call it neither. Take a moment, see if you can classify those, and if it's arithmetic, tell the common difference. If it's geometric, tell the common ratio. you're not done, push pause, but I'm going to go on. 21, 26, 31, 36 looks like an addition pattern. Looks like we're adding 5 every time. I'm going to call this arithmetic, and I'm going to say that my common difference is 5. In the next one, well, 4 plus what gives me 6? 2. And 6 plus what gives me 10? 4. Plus 2 plus 6, plus 2 plus 4 plus 6 plus 8. It's an addition pattern, but we're not adding the same thing every single time. There is no common difference. This is neither. Although there is a pattern, it's neither arithmetic nor geometric. Finally, in this one, looks like we're multiplying by 2, and multiplying by 2, and multiplying by 2, and this looks geometric with a common ratio of 2. Let's take a look at arithmetic sequences in more detail now. On the next page, if we have a sequence that's arithmetic, we want to be able to write a recursive formula for it, an explicit formula for it, and then be able to use that explicit formula to find a much later term in our pattern. The recursive formula for an arithmetic sequence, well, I'm just going to say from yesterday. This is nothing different than what we did yesterday in class, where we said the a1 equals something and the an equals an minus 1, and so on. We'll look at one of those in a moment. To create an explicit formula, well, let's see what we can do here. The first term is just a sub 1. To get to our second term, we're going to take our first term and we're going to add our common difference to it. So a1 plus the common difference gives us our second term. To get our third term, I'm going to add another common difference to this thing. It's going to be a1 plus d plus another common difference, so it's really going to become a1 plus 2d. We can get the third term by taking the first term and adding that common difference twice. To get to the next term, we're going to take our starting term of a1 and we're going to add our common difference one more time, a1 plus 3 common differences. To get to the 8th term, we'll take the first term and add 7 common differences. To get to the 20th term, we'll do a1 plus 19 common differences. And to get to our nth term, we're going to take the first term and we're going to add our common difference n minus 1 times. Our formula we're going to use for any arithmetic sequence is an equals a1 plus d times n minus 1. In that first example, we have an arithmetic sequence. Looks like we're adding 3 every time. To write the recursive formula, again, this is exactly what we did yesterday. We're going to say a1 equals 23, and we're going to say an equals an minus 1. And what are you doing to every previous term? You're adding 3. The explicit formula will just involve taking that formula that we just created and filling in the a1 and the d. Our explicit formula is an equals a1, that's 23, plus my common difference is 3, and I'm going to multiply that by n minus 1. This is my explicit formula. Take a moment and try both of those for letter B. See if you have some formulas that look like those. Next, we want to write an explicit formula for this sequence and then find the 25th term. Well, before we do any of these, we really should make sure it really is an arithmetic sequence. But it looks to me like we're adding 7, adding 7, adding 7. Yep, it's an arithmetic sequence. My explicit formula is going to be an equals the first term, which is 21, plus my common difference, which is 7, and I'm going to add that common difference n minus 1 times. To find the 25th term, all I need to do is plug in 25, and I'm going to say 21 plus 7 times 25 minus 1. At this point, go to your calculator, type it in, 21 plus 7 times 25 minus 1 should be 189. The 25th term in that pattern is 189. Try letter B. Common difference here is negative 12, so I could say plus negative 12 times n minus 1. I might as well just simplify it, though, to 217 minus 12 times n minus 1, and that's my explicit formula. Plug in your 11, 217 minus 12 times 11 minus 1, type it in, and we should get 97 for our 11th term. Now we're going to go and redo everything we just did for geometric sequences. It's a slightly different formula, but we can do the same sorts of things with geometric sequences. On the next page. To get a recursive formula for a geometric sequence, once again, I'm not going to bother doing this. We're just going to say from yesterday. This is nothing new. For our explicit formula, the first term is a1. To get the second term, I multiply the first term by the common ratio. So I'm going to say a1 times my common ratio. To get the third term, I'm going to multiply by that common ratio again, a1 times r times another r. But I can clean that up and just say a1 times r squared. And that's my third term. The first term times the common ratio again. To get to the fourth term, we'll take the first term, multiply it by the common ratio, and again, and we're going to get a1 times r cubed. To get the fifth term, we'll multiply the first term by the common ratio 4 times. To get the 10th term, we'll multiply the first term by the common ratio 9 times. And in general, to get the nth term, we're going to do the first term times the common ratio to the n minus 1. To write a recursive formula for what we see in example A, well, a1 equals 4, an equals the previous term, so a sub n minus 1, times 2. Our pattern is multiplied by 2 every time. For the explicit formula, we're going to say an equals the first term, 4, times our common ratio is 2, to the n minus 1. That's my explicit formula. Try letter B. Anytime that your ratio is either a fraction or a negative number, it's actually going to be very important that we plug it in parentheses, that we put parentheses around that 1/2. It will affect some of our calculations as we go to find some specific terms moving forward. In letter A, we want to write an explicit formula and then use it to find a specific term. Well, an equals the first term, which is 12, times our common ratio, which is 1/3, to the n minus 1. I then want to find the 10th term, so a sub 10 equals 12 times 1/3 to the 10 minus 1. Go to your calculator. We can type it all in one step as long as we're careful with our parentheses. 12 times 1/3 in parentheses raised to the, make sure the 10 minus 1 goes in parentheses, or just skip that and type in 9 right away. I'm getting something in scientific notation. If you have a graphing calculator, you should be able to push math, convert to fraction, and then enter again, and it should convert it to a fraction. If it doesn't, just leave it as a decimal, but make sure you use appropriate scientific notation, so 6.0966 times 10 to the negative 4th. Don't give an answer with an E written in it. Give it in normal scientific notation. Try letter B. Sure your common ratio is going in parentheses. Negative 564,875. There's one last thing that we took a look in class. An arithmetic and a geometric mean. The mean will help us find the term that is in between two terms. The mean is the term in between two terms. So the mean of 7 and 23 would figure out the middle term. The mean of 11 and 29 would figure out the middle term. Now, if we have the sequence 7 something 23, honestly, that middle number could be anything. Could be 8, could be 22, could be 20, could be 57. If I tell you, however, that this is forming an arithmetic sequence, there's only one number that could be. There's a formula for the arithmetic mean that would find the term in the middle of an arithmetic sequence. This is our regular mean or average formula. We're going to find the sum of two numbers, and we'll just divide that by 2. So in this example, the term in the middle is going to be 7 plus 23 divided by 2. That's 30 divided by 2. That's 15. Did it actually work? Is this actually arithmetic? Well, 7 plus 8 gives you 15. 15 plus 8 gives you 23. Yeah, it's arithmetic. There's a common difference of 8. Same thing in the next one. Middle term is going to be 20. If we have 3 missing numbers, well, if I did the arithmetic mean of negative 8 and negative 6.4, I'll find the one in the very middle. Negative 8 plus negative 6.4 divided by 2 will give you negative 7.2. Now I can do a similar thing to find that middle term and that middle term. We should get negative 6.8, negative 7.6. This only works if we have an arithmetic sequence. If instead the sequence was geometric, we need to find what's called the geometric mean. And actually, you use this in geometry to find some segments inside triangles. We're going to use it for our purposes of finding the middle term in a geometric sequence. Our formula for a geometric mean, rather than adding two numbers, we're going to multiply them. And rather than dividing by 2, we're going to take the square root. Our formula is the square root of the product of two numbers. What's in the middle of a geometric sequence with 20 and 80 on the outside? Well, I'm going to do the square root of 20 times 80. Go to your calculator for this. Square root of 1,600, you're going to get 40. In those last two, square root of 28 times 5,103, you're going to get 378. And with this one, same thing we did before. We'll do the product of those outer two numbers and then take the square root of them. You're going to get 22.5. Over here, we'll do the square root of 2.5 and 22.5. That gives us 7.5. And over here, we'll do the square root of 22.5 and 202.5, which will give you 67.5. And yeah, this thing looks geometric, times 3, times 3, times 3, times 3. Yeah, it worked. And that was all we did. We didn't get to the word problems. We'll talk about those on Tuesday.